Good afternoon to everybody. My name is Diego Pinto. I am going to introduce the word entitled Parallel Evolutionary Biclustering of Short-Term Electric Energy Consumption. This work is made in the framework on an energy efficient project of the Ministry of Science and Technology of Paraguay called PAIEM 1861. The project is sponsored by the Universidad Americana of Paraguay, and those responsible of this project belong to the private and university sector at the same time.
হ্যালো, হ্যাঁ আমি কল কেটে দিচ্ছি, তার মানে তো আমি ব্যস্ত আছি। আমি প্রেজেন্টেশন রয়েছে, তার মধ্যে তুমি দুইবার কল দিয়েছো।
Sorry? Can I continue?
Yes, please. Yes, please.
Okay. This is our agenda. First, I will introduce the short-term electric consumption concept. Then we are introduce the biclustering, that is machine learning and supervised machine learning bicluster. And then we are introduce our evolutionary bicluster, the parallel evolutionary bicluster, that is our principal contribution. And then we show some result on real problem or the simulation result and conclusion in future work. So in commercial and residential energy consumption, actually is the consumption is increasing over time. Here we can see an annual energy outlook 2021, where we can observe how the energy consumption in commercial and residential increase, and this is the projection to the future. That is very important to develop computer tool to help to predict consumption behavior in order to design policies to residential and commercial in the short term evolution. In this paper, in consequence, we address the description or try to find the pattern in the short term electric consumption. Given this is the variation in short term is the main problem for a small and medium area of the electrical energy consumption, like a small area where you have around 100 and 1,000 point of consuming. In this context, the short-term consumption pattern is studied in time lapse, typical ranging from 1 day to 1 month. From medium term and large term is studied in other context when the average of the a city or a country is the interest. In short-term electrical consumption, the data is like this example. We have several series time independent, where this information or this series time is sensed by sensor, the energy sensor. For example, a residential can have a sensor monitoring the consumption, or a commercial a specific sensor. In this context, the structure is a sequence of samples from many electrical sensors. This is described as a data matrix where each row corresponds to a sensor, and the column of the sample has shown in the figure. In this example, we have 5 electrical consumption sensors and 4 consumption sample. The sample may be maybe can take in every 1 hour or or 2 or 3 samples per day. It depends the precision on the information that engineering have needed to study. Here we can see a sound pattern that hiding in the D matrix. Although electric consumption is random, there are hidden patterns that we can need to find. The example shows 3 consumption patterns in different periods with different sensors. Here we can see the one pattern corresponded to 3 sensors and 11 sample corresponded 11 days. The variation on the energy consumption. Here we have another pattern, and here we have another pattern consumption with different sensor and different period of the time. This information is key to building policies to help to improve the efficient use of the electricity energy in the future. This is very important task in the machine learning and supervised machine learning called biclustering in order to describe this pattern in the electrical consumption. Before here we have a basic concept in order to remember what is a clustering. Given a data matrix, typically a clustering try to describe or determine a subset of row or column. This is the clustering. Depending on the distant uses, we can find different cluster in the problem. The distance or measure between that define the cluster is dependent on the problem. Naturally, each subset making a cluster. Here we can see in the clustering by row to be clustered and the column to be clustered as an example. Another kind of extension of clustering is the two-way clustering, where first the algorithms try to find the clustering in the row, and then for each cluster in the row, the algorithm is applied to find cluster in the column in the two-step way. But in the big cluster, the problem is to find a subset of matrix inserted in the data matrix, where the goal of the big cluster algorithm is to identify homogeneous submatrix. We can find here submatrix either not compacted and not consolidated, and this matrix can be, the submatrices can be overlapping with one to other, and each submatrix make up a cluster, and this cluster can use to describe or to discover the energy consumption pattern. This is an example of real pattern or real data matrix obtained to the electrical energy consumption. In the row corresponds to the 5 sensor, and we per sensor we have 40 sample corresponding at 2 samples per day. This is a micro study of the 20 days for 5 residential or commercial consumption energy. In the power consumption problem, we are interested to find the big cluster of contiguous column This is our principal interest. In the row, maybe the sensor belong to different location, but it's not a restriction to contiguous. But in the time, it's necessary to contiguous in order to describe the information to the transition of the information with a subset of sensor taken. In this problem, we consider the big cluster can be overlapping, and a big cluster is the tool that perfectly describes a pattern of consumption in a tiny span associated with the fixed sensor. In the example, we can see 3 big clusters corresponding to 3 pattern consumption, the real pattern consumption. This problem is very difficult because the quality of measuring are not linear, are not a linear function, optimization function, and at the same time, the number of big cluster, the possible big cluster in the matrix increasing exponentially with the number of row and the number of column. In this study, we consider the virtual error, row variance, and volume as a measure to characteristic or to define a quality or the quality of desirability of a submatrix big clustering. The virtual error is a measure the coherence or tendency, defining principally how the comportment of the every sensor in the time. Lower value refer to the more robust pattern in the big cluster. At the same time, in the electricity consumption, we want to capture or catch variation. A flat pattern is no problem, but the variation, abrupt change, and the consumption is very important to detect, to define. So we are looking for high variation on the row. We can see the variation of the peak of variation on the row here in the big cluster 3, for example. And the virtual error define the variation in a homogeneous way with the different sensor when the time changing. At the same time, we try to find large big cluster considering on the number of element big cluster. We try to the algorithm seek to find a big submatrix inserted in the data matrix. This measure is referring to volume. High volume is very important because the algorithm tried to find a large number of sensor and a large sample in the homogeneous average. In this study, we extended a previous algorithm based on evolutionary algorithm. We try we develop a system, a parallel system, and the name of this algorithm is Parallel Evolutionary Bicluster, which structure is shown in this part of the exposition. The big cluster problem, suppose I say, is an NP-hard problem. whose the zero space grow exponentially with the number of rows and columns. For that, we propose the architecture, the parallel evolutionary, in order to search in a big in the largest spacers in comparison with the traditional evolutionary algorithms in a sequential way. Our scheme is based on the master-slave paradigm, where the master and the slave or worker are run in different machines. At the end, at the first time, the master receives the matrix consumption, the consumption matrix, and then the master sends to each worker this matrix, and the worker work in the independent way, trying to find different bicluster in the same time. When the worker finally the task, they return the information or the solution to the master, and then the master consolidate the information and select the best bicluster or the pattern find in the matrix, in the data matrix. And how work what a worker node. Here we can see a particular operation of a node where it's based to sequential evolutionary biclustering called SEBI. This algorithm find each bicluster or each submatrix in a sequential way. Every bicluster is found at the end of the evolutionary process, and then another bicluster is searched by another evolutionary process. So evolutionary, the SEBI, after find a bicluster, the position of the bicluster is penalized to avoid recalculation to the same bicluster for in the next step. This is very important because in the first step, the algorithm will be find a good bicluster, and then in the other in sequential step, the algorithm will find another bicluster but the slow quality. So in order to avoid to repeat in the convert to avoid the convergence to the same bicluster, is necessary to modify in the position of the value on the matrix using a penalization. After that, in the next sequence, considering the new matrix modified, again the algorithm is scaled, and this evolutionary algorithm find the new a new bicluster. And in this way, after k step, k different bicluster are discovered by sequential optimization, evolutionary optimization of the one evolutionary algorithm invoked by the SEBI. So in our study, we consider real data, that consumption of 184 residents. We have taken 744 samples corresponding to consumption to the month of December 2013. this information or the database are local on our country, in the small city in the Paraguay. This is a real information, but not is public this information again. We perform this algorithm considering different number of worker or slave. We perform the algorithm considering 2, 3, 4 to the 10 slave, and the result was compared with the conventional evolutionary algorithm, and the relative performance of the parallel of the sequential evolutionary is present in this figure. We can see here that the parallel approach is very convenient, because when the number of slaves increases, the solution of the quality of the bicluster funded is increasing, is better. We can see here in the blue line corresponding to fairness. At the same time, we can see here the three methods, the virtual error, the raw variance, or the volume that improve when the number of the space is the space of the set of state increasing, we find better solution. It's very important to notice that that fitness, the fitness and the volume and the virtual error have a high correlation. At the same time, virtual error and volume present a high correlation, but when the virtual error and volume improve, at the same time when the number of slaves increases. Here we can see some real solution for the data gathered in December, and we can see here how our algorithm is available to find a pattern with a high coherence. The high coherence is measured through the virtual error. At the same time, we can see here several sensors and several periods of the time indicating a high volume of this bicluster. The algorithm found 10 good quality bicluster, but in this presentation we just show only two patterns of the real solution. Here we can see a virtual error that is a little worse in comparison with this pattern, and but the variation is improved here, and here the variation is a little small in comparison. So it's very important that our algorithm can detect the coherence and a pattern coherent with high variation in the time. So the summary of this work is the same. We can develop parallel evolutionary algorithm for the biclustering problem in general. We apply this algorithm, this parallel algorithm, for the short-term pattern consumption electric, because the biclustering is the task that can be discovered the consumption pattern in short-term electrical consumption. We define quality measuring like virtual error, rho, and volume, in this quality measuring, we can find to give the evolutionary process or the evolutionary search to find good pattern or good biclustering. In the future, we try to extend the work in multi-objective optimization approach because the virtual error and the volume are objective function in relationship, are objective function contradictory. When virtual error improve, the volume worsens. At the same time, we try to explore another parallelization paradigm, like Iceland parallelization. We consider the fear and traditional parallelization master-slave. And we are interested to study in the future the pattern with displays in the time. In this world, we consider that the pattern is in the same window time, the old sample. What happened is the sample is of the one sensor have the same pattern or is the similar or high coherence with other sensor, but in other point of the time. Okay, thank you very much for your attention.